One-way analysis of variance, or ANOVA. So analysis of variance is a technique used to determine if samples, in terms of the difference of means, differ from each other significantly. And unlike a t-test, an ANOVA analysis of variance can compare more than two means. So let's go ahead and get our data set. The data is called cgrades.save. So in our model, we're trying to determine whether there are differences in the test scores of persons that come from 5 different cities. Now, ANOVA must always consist of a continuous dependent variable, like quiz. So either lots of categories that are ordinal, or a continuous variable measuring real numbers. Here, with a quiz, we have grades that can go from 0 to 100%. And the independent variable must be a categorical independent variable, not an ordinal, but categorical, like the city you were born in, right? There's no obvious hierarchy involving cities. So this is actually the complete opposite of a logistic regression, in which the dependent variable is categorical and the independent variables should be continuous. Here, in an ANOVA, it's completely reversed. And there are times when this type of analysis is worthwhile. So there's some definitions for a one-way analysis of variance procedure. First of all, a factor is an independent variable. What we're going to contrast are subgroups. Now, technically, this requires the entry of values that sum up to 0. For example, 1, 1, 1, minus 3. All those added up together are going to equal 0. And one of the tests we're going to be using is an LSD, a least significant difference. So this is the procedure. We go to Analyze, we go to Compare Means, and we go down to one-way ANOVA. Now the dependent variable here, the outcome, is the performance on quiz 4. The factor is birth city, or the city where the people came from. Now we go to Options, and here we click on Descriptives under Statistics and Homogeneity of the Variance Tests. And we click Continue. Then we go to Post Hoc, and we click here on the different tests. The LSD, the Sheffey, and the Bonferroni. And we click Continue and OK. So here we have a number of tables. Let's look at the first table. The Descriptives gives the average score of each of the different cities. So we can see here the number of individuals from the different cities, their mean score, which varies from a high of 8.35 down to 6.27. It gives the standard deviation based on the distribution of those scores with a standard error. It gives us the confidence interval around the mean for 95%. It gives us the minimum value and the maximum value. So, looking at the ocular trauma test, it looks like, the people from City 5 performed much worse on average than the people from City 2, right? It looks like there's almost a 2-point plus difference between those grades, right? Of course, there's a much higher standard deviation, so the distribution is quite wide. You do have someone with 10, a score of 10 in the group that comes from City 5. Okay. In general, though, if you look at City 2, the minimum grade is a 6, where the minimum grade for City 5 is a 2. So, it looks like ocular trauma test that there's a difference between Cities 2 and Cities 5. Now, Table 2 is the test of homogeneity of variances. It uses the Levine statistic. It measures the difference of the variances, a failure of which would suggest a check on kurtosis and skewness to ensure the normality in the variables, particularly the dependent variable, which is a quiz. Obviously, you're not going to have normality in the independent variable. So you can see here the significance is 0.004 based on the mean. There are other measures here as well, but the mean is the most important, and it passes the test. Table 3 is the ANOVA. The key measure of significance of differences is the significance of the F statistic. So this is a normal interpretation of an F statistic. Here, it shows us that the results of the test cannot be generalized. It looks like we have a false positive or a coincidence. It looks like the difference between city 2 and city 5 is not a real difference, or the difference between the other cities are not real. So here we have the post-Hoc test. It's a multiple comparison. Here for Sheffy, you can see you've got the 5 cities of origin, and then you've got it in comparison with the other cities as subcategories. And here it shows you the mean difference, which turns into a standard error, and then a significance. These significances are interpreted conventionally, and if they're significant to 0.05, it's going to show us as an asterisk on the mean difference to show us that the value is in fact significant. So let's go look for some asterisks. Okay, so we go down here, and we find none here in the Sheffy test. All right, so Sheffy says every single possible interaction between those cities shows that despite the it looks like that the grades are different among the cities, they're not. At least not statistically. So we do seem to have a difference between 2 and 5 for the least significant difference. So the intuition is correct. There is a difference for this particular test, but not for the Sheffy test, between city 2 and 5. We also have a difference between cities 4 and 5. And again, here we have 5 and 2 and 5 and 4. Let's go take a look at city 4. City 4 has got 45 cases, a high score of 8. And it looks like, yeah, 5 and 4 have a difference. So city 2 and city 4 are similar, and so they both have a significant difference according to the least significant difference test. Now let's look at Bonferroni. No asterisks at all. So you have 3 different tests here, and what we're left with is that LSD indicates there's a difference. Sheffy and Bonferroni don't, and so the next step would be to go and investigate the specifics and how liberal and how conservative those particular tests are.